Alright, so this is an example of a linear equation word problem. Okay? Linear equation word problem. So let's see what kind of information they give us. In this linear equation word problem, they can either give me a slope and a point, allowing me to write an equation, because if you look at number A, letter A says find an equation that models the situation. They give me 2 points, which allows me to find the slope, and then use point slope. Okay? Or if they were really nice, they would give me the slope and y-intercept, and then that would be enough to write the equation as well. Okay? So let's see what this says. Right? So biologists have found the number of chirps some crickets make per minute is related to the temperature. And this is all true. Okay? So if you ever hear a cricket outside, depending on the temperature, it depends on how many chirps you'll hear them the crickets chirp. So the relationship is very close to being linear, which is why it's a model. Okay? It's not perfect, but it's going to be a good model for a linear equation. When crickets chirp 124 times a minute, it is about 68 degrees Fahrenheit. When they chirp 172 minutes, it's about 80 degrees Fahrenheit. So I'm going to define some variables here. So I'm going to let x represent the temperature outside, the temperature in degrees Fahrenheit. And I'm going to let y equal the number of chirps. Right, it doesn't tell me to use any specific variables. I'm going to choose my own. So I'm going to use x and y just for fun. Okay? So when the cricket chirps 124 times, it is about 68 degrees Fahrenheit. So I can't control the temperature. Okay, so the temperature is independent. So as a coordinate, when it's 68 degrees, there is 124 chirps. So the chirps depends on the temperature, right? So the chirps will depend on the temperature. I can't control the temperature, so the temperature is an independent variable, but the chirps will depend on what the temperature is outside. And then the second coordinate here is they're giving me is when they chirp 172 minutes, it's about 80 degrees Fahrenheit. So as it's getting warmer, you're hearing them chirp a little bit more. So 80 degrees Fahrenheit means that there's about 172 chirps per minute. So now here's a linear equation word problem that has given me 2 points. What can I do with these 2 points? Well, any equation I need, I would need a slope to write the equation, so let's start there. What's my slope? So my slope is m equals, I've used my coordinate, my formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to label my coordinates, keep me on track here, so x sub 1, y sub 1, x sub 2, y sub 2, and it didn't matter which one was my x sub 1s and y sub 1s, or x sub 2s and y sub 2s, I could interchange those, okay, that will make a difference. And then I'm going to substitute in, I have 172 minus 124 over 80 minus. Alright, so I'll give you a second to work that out. If you did, you would get 48 in the numerator, 12 in the denominator, with the magic number of 4. What does that mean? Alright, so 4 chirps per degree Fahrenheit. So as you get an increase of 1 degree, you should see an increase of 4 chirps per minute. I'm sorry, 4 chirps. So every degree increase in Fahrenheit will have 4 more chirps. You'll hear 4 more chirps. So now I have a slope and I have a coordinate. I have 2 coordinates. Choose any one, and I can now use point slope. Point slope form will help me write my equation. So point slope is an equation, right? So what's point slope? Y minus y sub 1 equals m times the quantity of x minus x sub 1. I have my slope of 4. I have my coordinate x sub 1, y sub 1. I'll choose. And I'm going to substitute in my 4 for m. My 124 goes in for y sub 1. My 68 goes in for x sub 1. And everything else stays the same. So y minus 124 equals 4 times the quantity of x minus 68. technically that's my equation. Right? It says write the equation. It didn't say what form to write the equation in, so this would actually suffice. This is point slope form. It's a linear equation, so I'm done. I'm going to take this a little step further, and I'm going to put this into slope intercept form. So slope intercept form, I'm going to distribute my 4. So y minus 124 equals, distribute the 4 to x. 4 times x is 4x. And then I'm going to distribute the 4 to negative 68 here, which is negative 272. And then I'm going to take one more step and bring this positive 124 to both sides, xing that out, and I get y equals 4x minus 148. I'm going to pause there for a quick second. As I pause there, I'm going to think about this equation. Y equals 4x minus 148. I know what the 4 means, right? The 4 is my chirps per degree. What does that negative 148 mean? What's that b value? What does that represent? Negative 48. So in my equation, I put this in y equals mx plus b. B is my y-intercept. Okay, great. So m is my slope, b is my y-intercept. What does that represent, the negative 148? Right? The b is where you start. Right? This is my starting point. Can I start with negative 148 chirps? Have you ever heard a cricket chirp negative 148 times? And the answer is no, right? So that's not possible to have that. And that's why when they say write an equation that models the situation, right? At some point you're going to have chirps that work, but when they model the situation, that linear equation that they modeled will fit this equation, or will fit all this data, but again, it's going to go into some scenarios that may not be 100% true, and that's why it's just a model. So this is when we come back to some key words here that we have: domain and range. All right, what's the domain of this function? What's the smallest, or what's the least amount of chirps that can happen here? Right? What's our coordinates are 68, 1, 124, so 124 chirps. 80, 172. So what's the smallest amount of chirps you can have? If you walk outside, you hear some chirping. What's the smallest number of chirps you can have? Well, you can walk outside and you can hear nothing. That would be the smallest amount of chirps. So the smallest y value you can have is 0, and we can figure out what the x value would be with that as well. All right, so we have to restrict our domain to this, but it still would be a linear model that would work. Okay. So here's the next question. So that was part A. Part B says, how warm is it when the crickets are chirping 150 times per minute? How warm is it when the crickets are chirping 150 times per minute? Well, if I go back into my definitions, what does x represent? X is my what? Temperature or chirps? Yep. X is my temperature. Y is my chirps. So in part B, crickets are chirping 150 times per minute. Am I giving you an x value here, or am I giving you a y value here? All right, so if you go back to what you defined your variables to be, the 150 chirps per minute, this is a y value. So when I have my equation, y equals 4x minus 148, and I'm given a value of 150, I have two choices. Plug this in for y or plug this in for x. Well, 150 times chirping, 150 chirps is my y. So 150 equals 4x minus 148. So once you've established this equation, there's only two things I'm going to be able to give you here. I'm going to give you the y value, or I'm going to give you the x value. Which one is it? Right? And just look at the words that they're saying. 150 chirps. Okay, go back to my let x equal let y equal. X is temperature, y is chirps. Okay, so they're giving me the y value. So take that 150 and substitute in for y and solve. So I'm going to add 150 goes in for y, I'm going to add 148 to both sides. And I get 298 equals 4x. And then I'm going to divide both sides by 4. And x is equal to about 74.5 degrees. And this is in Fahrenheit. And now let's do the last one here, part C. If the temperature is 100 degrees Fahrenheit, the number of chirps some crickets make is what? If the temperature is 100 degrees Fahrenheit, okay, so they're giving you 100 degrees. You have your equation, y equals 4x minus 148. Am I giving you the x or the y here? Am I giving you a value for x or am I giving you a value for y? If the temperature is 100 degrees Fahrenheit, is that my x or is that my y? Okay, x is, go back to your definition of what you defined. X equal what? X is the temperature. X is the temperature. Okay, so 100 degrees Fahrenheit, so that 100 goes in for x. So my equation is y equals 4 times 100 minus 148. And 4 times 100 is 400. And 400 minus 148 is 252 chirps. So you could potentially be hearing 252 chirps per minute when the temperature is 100 degrees Fahrenheit. So here's another example, right? So an internet service provider charges $18 per month. All right, and that $18 per month is something I'm going to underline or circle here. Why? What is that telling you? The $18 per month. What does that 18 represent? Yep. Yeah, my slope is $18 per month, right? So the slope is $18 per month. And that per month is the hint there, right? So it's dollars per month. Dollars per month. And with that, that's also telling me the order my coordinates should be in. Is this going to be dollars, comma months, or months, comma dollars? Dollars, comma months, or months, comma dollars? Yep. Months, comma dollars. Awesome. So this is going to be months, and this is going to be dollars. Okay. And months is a form of time, and time is always going to be your x. Right? Time will always be your x there. So months, comma dollars, and then if I read on, plus an initial setup fee. Well, I don't know what that initial setup fee is. That's unknown for me right now. And it says one customer paid a total of $81 after 2 months of service. Okay, so there's a coordinate. What's the coordinate that's given there? $81 after 2 months of service. Is that 81, 2 or 2, 81? Yep. 2, 81. Perfect. Okay, so then you have 2, 81. So you have a slope of $18 per month, and you have a point of 2, 81. Well, if you have a slope and a point, then we're going to go to point slope form. Well, again, point slope form is y minus y sub 1 equals m times the quantity of x minus x sub 1. My 18 goes in for my slope. 81 is my y sub 1, goes in for, and 2 goes in for x sub 1. So when I write this, I have y minus 81 equals 18 times the quantity of x minus 2. Now again, for part A, it doesn't say what form to write this in. It just says write an equation to model this, and that would be suffice. But I'm going to take this a little step further into slope intercept form again because it's going to give me some extra information. It's going to give me that part B of what is that setup fee. Alright, so let's take a look at that. So I have y minus 81 equals 18 times x, which is 18x, and then 18 times 2, and negative 2, be careful, and you get negative 36. So then I'm going to add the 81 to both sides. And I get y is equal to 18x plus 45. So that's my part A. So I know the 18 is the slope, but what does that 45 represent? 18 is the slope plus 45. What does that 45 represent? I know it's the y-intercept, right? And y equals mx plus b. Yep, what does that 45 represent? Yes, my startup fee. It's my initial fee. So in part B says, what's the initial fee or initial setup fee? It's $45. So by taking that equation in point slope form and converting it into slope intercept form, you've actually answered A and B just in that one step there. Then looking at part C, right, this is why getting that equation is critical. Part C says, how much does it cost after 5 months of service? Okay, so I have an equation. Y equals 18x plus 45. I'm going to use this equation. What is that 5 months? Is that my x value or is that my y value? Which value is that? Is that the x value or is that the y value? 5 months. And when you labeled your information here, you had months, comma, dollars. So that 5 is what? That's my x value there. So when I go back into my equation, I have y equals 18 times 5 plus 45, which is 90, plus 45, which is equal to $135. So 5 months of service will cost you $135. I'm going to add a part D to this one. What if you spent $261? If you spent $261 with this company, how many months of service have gone by? Or how many months of service have you gotten? If you spent $261, how many months of service? What am I giving you here? The 261. What is that? You have two choices. Is it X or is it Y? The $261. Is it my X term or is it my Y term? What am I giving you?
You put in Y?
Y, yeah, awesome, right? $261 is your Y term, right? So X months, comma, dollars. Y, dollars is my Y. 261 is dollars. So 261 equals 18x plus 45. And then I'm simply going to take that 261 and subtract the 45 from there. And I get 216 equals 18x. And then divide both sides by 18 here. Sorry for the room right now. And I get x is equal to 12. 12 what? 12 months of service.